Hello everyone, welcome back to my channel. Today we're going to be looking at factorizing cubic polynomials. But before we get into factorizing cubic polynomials, the first and most important question is, what is factorization? What happens when you factorize? Now we define factorization as writing an expression or a term as a product of factors. What do I mean by that? For instance, if I were to factorize 6, I could write 6 as 3 times 2. The same can be applied to expressions. So if we have, for instance, a quadratic, let us say we have x squared plus 4x plus 3, then this can be written as product of linear factors. Now, alright, and we can use a shortcut here because the coefficient of x squared is 1. So we want two terms. If we multiply them, we get 3. Or two numbers, if we multiply them, we get 3. And if we add them, we get 4. Those two numbers would be 3 and 1. So if I factorize this, it's going to become x plus 3 times x plus 1. And the fact that this is quadratic, or we can also call it a second degree polynomial, we do expect to get two linear factors, which are x plus 1 and x plus 3. So if we were to take a cubic polynomial, which the highest power or the degree of the polynomial is 3, we would expect to get 3 factors. Alright, and let us get right into it. So here's an example of a question. It has two parts. It says, show that x minus 2 is a factor of f of x equal x cubed plus 2x squared minus 5x minus 6. Hence factorize f of x completely. So we're going to be looking at two different instances. One where you're actually given a factor, and one where you're not given any factors at all, and you have to factorize. Now, this question has two parts. I'm going to deal with part A first. Now, part A would naturally use the factor theorem. Alright, so we're going to say let x minus 2 equal 0. This implies that x would be equal to 2. Now, if x minus 2 is a factor, this implies that f of 2 would be equal to 0. So when I plug 2 into this, there wouldn't be any remainder. I would end up with 0. So let us test the theory and see what happens. I'm going to have 2 cubed plus 2 times 2 squared minus 5 times 2 minus 6 should be equal to 0. Alright? And I could use my calculator to put in all of this. Now when I plug all of this into my calculator, I'm going to end up with 0 equals 0. So therefore, x minus 2 is a factor of f of x. So that is just looking at it from the perspective that they could give you that as a part A to this particular question, or they could have given you the factor in some other ways, right? That's one way to look at it. So we have proven that x minus 2 is a factor. And now it's going to be time to actually factorize the expression. Now we're going to be factorizing the polynomial completely. And the conceptual idea behind it is this. Think of 6. If I want to factorize 6, and I know that 3 is a factor, all we need to do is to divide 6 by 3 to get the other factor that we multiply 3 by to get 6, which would be equal to 2. So now we know that 6 is really equal to 3 times 2 when we factorize it. The same concept will be applied in this scenario. So we have one factor, which is x minus 2. That is my divisor. I'm going to be doing this the traditional method. X minus 2 into my dividend, which is x cubed plus 2x squared minus 5x minus 6. Now we say x into x cubed would be x squared, and we multiplied x squared by my divisor, which is going to give me x cubed minus 2x squared, and then we subtract. So we know that x cubed minus x cubed is 0, and 2x squared minus negative 2x squared is 4x squared. We then carry down the minus 5x, and we start the process over again. We say x into 4x squared would give me a positive 4x. Now 4x multiplied by x minus 2 would be 4x squared minus 8x. And we subtract again. But what is imperative here is that we pay keen attention to the signs. So 4x squared minus 4x squared is 0. But what about negative 5x minus negative 8x? These two consecutive minus signs would actually give me an addition sign. So I would be saying negative 5x plus 8x, which is going to give me a positive 3x. I will carry down the minus 6. Now x into 3x would give me a positive 3. And 3 times x minus 2 would give me 3x minus 6. Now, how do I know that my division is correct? Now, notice one indicator is that you don't have a remainder. Because when you divide by a factor, you cannot have a remainder. Alright? So we can now say that f of x is actually equal to x minus 2 times this quadratic factor, which is x squared plus 4x plus 3. But since this is quadratic, it means that this is incomplete factorization. So I'm going to have to go back and factorize a quadratic expression. Of course, we can use a shortcut in this case as well, because the coefficient of x squared is 1. So we want two numbers. When we multiply them, we get 3, but when we add them, we get 4. That would be 1 and 2. So f of x would actually become x minus 2 times x plus 1 times x plus 3. And that is complete factorization. I now have f of x written as a product of 3 linear factors. Alright, here's example number 2. We're given an expression and we're asked to factorize it. In this particular case, we're not given a linear factor. So it says factorize the expression x cubed plus 3x squared minus 10x minus 24. So we are going to have to determine what a linear factor is. But how do we do that? We're going to have to use a process known as trial and error. So we need to find a number that when we replace x by it, we get 0. And of course, there's a special name for that. That is what is referred to as a root. Now, what is the trying process? We can start by trying x equal. So let's just call the expression f of x. So we say f of x equal. We can start by trying x equal 1. So we find f of 1. And bear in mind that we said that f of 1 would actually be a root. F of 1 would be equal to, and we can put that inside of the calculator. Now this would give me negative 30. So I know right away that x equal 1 is not a root. X equal 1 doesn't work. So that is out. Let me say not applicable. We could then try x equal negative 1. And here's the beauty. Sometimes when we look at it, we know that 1 won't work. Because to try x equal 1, all we have to do is ignore all the x's and work with the coefficients. Because if we replace x by 1, it doesn't really change the values that we have here. Let us try x equal negative 1 and see what happens. So when I plug this into my calculator, f of negative 1, I get negative 12, which is also not applicable. Alright, so we move on to 2. Try x equal 2. So f of 2 equal, and then again we said this is a job for your calculator. This gives me negative 24, so also this is also out, not applicable. Now if I try x equal negative 2, so we try positive, then negative, then positive, then negative. F of negative 2 would give me 0. So right away we have our factor. So if we know that x equal negative 2 works, it means that negative 2 is a root, which would mean that x plus 2 is a factor. Alright, and once we have a factor, we can go ahead and we can find other factors by doing long division. So we're going to have x plus 2 as our divisor into x cubed plus 3x squared minus 10x minus 24. And we know the process. We say x into x cubed is going to give me x squared. Now x squared times my divisor is going to give me x cubed plus 2x squared. And we subtract. Now x cubed minus x cubed is 0. But 3x squared minus 2x squared is positive x squared. And we carry down the minus 10x. X into x squared would give me a positive x, and x times x plus 2 would give me x squared plus 2x. And of course, we apply the process of subtraction again. So we have negative 10x minus 2x, which is going to be minus 12x minus 24. Now we say x into minus 12x would be minus 12, and minus 12 times my divisor would be minus 12x minus 24. Once again, here's an indicator that I did it correctly because my remainder is 0. So f of x is equal to x plus 2 multiplied by my quadratic factor, which is x squared plus x minus 12. And we say once again, we need to factorize a quadratic, and we can use the shortcut because the coefficient of x squared is positive 1. So we want two numbers. If we multiply them, we get minus 12, but if we add them, we get positive 1. Those two numbers would be positive 4 and negative 3. So I'm going to have x plus 4 and x minus 3. And this, of course, is complete factorization. And that is the end of the question.